Hi, welcome to STEAM Kids Virtual Classroom here at the Colorado Model Railroad Museum. I'm Michelle Kempema, the Executive Director here, and I have Peter Romero with me.
Science Geek Extraordinaire.
Yep, that's the title we gave you.
Yeah.
We're talking about space, and we've done some work on space before, but now we're going to talk about some specific planets. I'm really excited about this. So.
We've done a lot of talking about Mars with Perseverance and everything, and that's been exciting. I watched the landing of that, and did you watch it too?
I did. I watched it later. I didn't get to watch it live, but there's so much that's come out of that. Just the parachute and so many things we talked about.
The wind recording.
Yeah, and now we get to see all that in action. It was neat.
It is. But there are more planets than Mars in our solar system.
Yes, there are. So we're going to focus on the outer planets today.
Yeah, so there are three kinds of planets. There's rocky planets, which Earth and Mars are, and then there are gas giants and ice giants.
Wow. So I wonder which two are gas giants.
Well, there's four outer planets: Jupiter, Saturn, Uranus, and Neptune.
Yeah.
And go ahead.
Yeah, no, I was going to say, there used to be one called Pluto, but they declassified it as a planet.
It didn't disappear. It's still there.
It's still there. It's just not considered a planet.
Correct.
But your parents might think that Pluto's a planet because I grew up with it as a planet, and now it's not classified as one.
Right.
Just scientific classification changed. So
Nothing about Pluto itself changed, but just what we call it. But anyway, Jupiter and Saturn are the two planets we call gas giants. And then Uranus and Neptune are planets that we call ice giants.
They're very, very cold, right? They're just full of ice. And
so what all these planets have in common is they're really big, and they're made out of gases mostly instead of solid surfaces like the Earth has.
Yeah.
Gas giants are mostly made out of hydrogen and helium.
Okay, so part of what our planet is made out of, we have a little bit of that on our planet.
We do have a little bit.
Yeah.
But this is like an entire planet just made out of
that.
Mostly hydrogen and helium.
Wow.
And then ice giants are made out of hydrogen and helium, but they also have some other compounds in them like water, methane, ammonia.
So pretty deadly places for human beings, actually.
Yeah. Well, so they're further away from the sun.
Yeah, so very cold.
They're bigger, so they have way higher gravity.
Yeah, that's true.
And they also don't have a solid surface. So like in Jupiter's case, the atmosphere goes down for thousands of miles.
Oh, wow. So the atmosphere is just so much bigger than Earth's atmosphere.
Yeah, just like thousands and thousands of miles of hydrogen and helium, and then there's no solid surface. It just like kind of gradually changes to liquid, and then the liquid gradually changes to solid.
And then you're at the core, and then you start on the other side. Huh?
And they have so much pressure inside of the planets, like Jupiter and Saturn have a core of what we think is metallic hydrogen, which doesn't exist on Earth. We can't study it directly because to make hydrogen into a metal, you have to have like 3 or 4 million times as much air pressure as there is on Earth.
And we just can't reproduce that.
No.
That kind of pressure.
So on Earth, you can solidify hydrogen, but it's not a metal.
Wow, that's amazing.
It is.
Our universe is pretty amazing.
It is.
We were talking about size, and we printed a sheet for you kids to see. Just these aren't exact to scale, but it does give you an idea of the size of the planets. And you can see how much bigger Jupiter is than Earth. You know, and look how this one has Pluto. It's still listed on there. Sorry. But you can see how small it is, which is why it's not classified as a planet anymore.
Yeah, it's a dwarf planet.
It's a dwarf planet. And so you've got Mercury, Mars, Venus, and Earth, and then Neptune in size, then Uranus, then Saturn, and Jupiter's the biggest.
Yeah, so this is the correct order, but the sizes are not correct exactly.
It's not to scale.
Jupiter is about 11 times the diameter of Earth.
Wow, so that would be Earth 11 times wide would be Jupiter if it were to scale. So Jupiter wouldn't even fit on this paper.
Correct.
But this gives you an idea of the order.
And, you know, we were talking about how they're all made mostly of gases.
Yeah.
And they don't have a solid surface, so they have a lot of wind.
A lot of wind. Especially, isn't it Neptune that's the windiest?
Actually,
or is
Saturn.
it Jupiter? Saturn?
Saturn has the most wind. Saturn has 1,100 mile-an-hour winds.
Wow, that's really fast.
Can you even imagine?
No, that's what gives it the stripes, though, isn't it?
Yeah, it's
movement
like all
of the air.
Just blurred. And then Jupiter has a really turbulent atmosphere with lots of storm activity. Actually, if you look at this, this feature here, it's called the Great Red Spot. Yeah. It's a storm.
It's a storm.
It's a storm, and it's been there for over 350 years.
Wow.
It's 3 times the width of Earth. So just picture 3 little Earths in there.
Now, something that the stripes help us see is the angle of rotation
Yes.
of these planets. So if you look at our picture of Jupiter, you'll see it's angled a little bit.
You can tell where the poles are and where the equator
where the polar axis is, yeah, and where the equator, because the wind on it is moving
Right,
along,
it goes along
with that.
the lines of
Now,
latitude.
there's something really interesting about Uranus, though, that's really different. If you notice the rings on Saturn, the way we orient it, are kind of a little more level for us, but look at Uranus. Its rings go up and down. So why is that?
Well, actually, this chart shows it very well. So each planet has its axis inclined to a different degree. Earth's axis is inclined 23.5 degrees, which gives us seasons.
Right.
And most of the planets are fairly close to vertical, but if you look at this, Uranus's axis is almost horizontal. It's tipped all the way to the side.
It's 60 degrees, I think is what I...
This says
Does it
98
say
degrees, so it's
98
actually
degrees?
even
Wow.
a little bit past.
So it's even past. Wow.
And so so what that does is it makes Uranus rotate this way instead of
like we see it.
Yeah.
So if Earth were that way, it would be all messed up. We'd be completely tipped.
It does a weird thing to the seasons too, because Uranus takes a long time to go around the sun because it's so much further away. It has like an 84-year year. But so 42
Wow.
years of its year are spent in summer for one side,
Wow.
and 42 years in winter because of the way it's rotating sideways like that.
I'm not sure I'd want 42 years of winter.
I don't think I'd want
I think
42
that's a
years
long
of anything
time.
the same.
Yeah. Very
mentioned-
interesting.
The rings, now did you know all the planets, all the outer planets have rings?
I did not know that. I thought it was just these two.
They actually all do. You can't see the ones on Jupiter and Neptune very much because they're small and dark, but they all have rings.
But they're there. What are the rings made of?
Rocks and
Things,
small
are they in their
boulders.
gravitational pull, and and
Yeah.
they just end up in that to make the ring?
So the rings, like Saturn has these beautiful rings, and they're made of particles of rock, anywhere from like dust size, pebbles, all the way up to boulder size.
Wow.
Just zillions and zillions of them.
Just
And
rotating.
where you see the gaps in the rings,
Yeah.
sometimes there will be a moon that's orbiting in the same place as the ring, so it'll just clear out that path.
Oh, so that's where the gap is, would be where a moon is. Now,
Yeah.
all of these planets have moons, correct?
Yeah. Not just one or two.
not
Lots.
like Earth with our one moon.
Jupiter has like 60 plus moons.
Oh, wow, that's a lot of moons.
Yeah, because Jupiter is right next to the asteroid belt, so it captures all these moons. It has 4 big ones. Like in the 1600s, Galileo could see 4 moons from Earth.
That's amazing.
But it actually has way more than 4. And then Saturn has like 30, Uranus has 20, and
That's a lot of moons. Now, interesting, you mentioned Galileo being able to see the planets. How do we see the planets?
well, with telescopes.
With telescopes, right?
Mostly.
Yeah, and in the 70s, the late 1970s, they sent out Voyager 1 and 2 that actually were satellites that went past the planets and then went off into space in the 1990s. And so I think in 1996 is when it passed Jupiter and they took photos. And so we have some data of really good close photography of the planets
I think all of
starting in
these
the 1990s.
photos come from Voyager,
And
don't
then
they?
I think so. Or no, these come from Hubble. So Voyager 1 and 2 were kind of like Perseverance.
Yeah.
But they shot off into space and they will never come back. And they're gone out of our solar system now.
But Voyager was like the first time we had a close-up view of these outer planets. Before that,
Right.
we just had little blurry images from our telescopes.
From our
on Earth.
telescopes. Well, then NASA decided to build a giant telescope in space. And so if you've ever heard of the Hubble Telescope, which I have a photo of it here, Hubble was built in space. A lot of it went up in the shuttles, starting in 1990 with the shuttle Discovery. And then many more of NASA's missions continued to work on it and improve it. And to this day, this orbits Earth and takes pictures of our planets.
That is so cool.
So I remember when we were talking about how when we were going to launch to Mars, you have to have the right planetary rotation. Well, whenever any of these planets are perfectly across from the sun so that they have the most amount of sunlight possible on the planet, and Earth is in the right spot and Hubble's in the right spot orbiting Earth, that's when it takes its best photographs of those planets. And there's whole teams that work on just this data.
That makes
they
a lot of
keep.
sense.
Yeah, and so these photos come from Hubble. So it's pretty neat. There's actually, NASA has a whole website dedicated to Hubble and its photography.
Yeah, and they took pictures of other things besides planets too, galaxies. And...
Yeah, they can see really far with it now. And
Now, do you know why it's built in space instead of just
I
on
think
a mountain somewhere?
because it's so big to get it up there.
Another really good reason is the atmosphere. So when you go outside and look at the stars, they twinkle.
Yeah, because they're going through the air.
Yeah, the air kind of
Okay.
refracts the light, and so if you're looking through a telescope at something that's got layers of air that's making it twinkle and blur and shift, it's not as good
Right,
as if you're out in space.
That's totally true. I hadn't thought about that. That's why these are so clear.
Yeah.
Now they use different filters. Sometimes you might see a planet have a slightly different hue or color, and that depends on what filters are picking up
Yeah.
the hydrogen or the helium. And so
And the
it's
chemical
neat.
composition of the atmosphere actually is what gives it these colors.
Yes. So
So the different compounds that are in the air.
well, so there's some information about the outer planets.
Yeah.
Now let's make one.
We're going to do an activity where we've provided some Play-Doh in your bags that you picked up.
We have work surfaces here.
So we're going to make a planet. So we're each going to choose 2 colors,
Okay, I'm gonna
I'm
do
gonna pick-
purple for sure.
red
I like this one.
and yellow.
I'm gonna do these 2 colors.
And if you have the small Play-Dohs, just use the whole thing. If you have a bigger one, just use about half of it for each color.
Okay.
And we're going to take these and we're going to divide each one in half.
Divide these in half?
Yep.
Okay. All right. I can do that.
And then we're going to take each half and
Okay.
divide it in half
And
again.
divide it in half again.
Yep.
Okay.
Guess what's next?
Are we going to divide them
We're going to
again?
divide them again.
Okay.
So that's like 16 little pieces, just
All
as
right.
even as you can make them.
Okay. Do they need to be rolled into little balls?
Yeah, I was going to do that next.
Okay.
So yeah, just take each one, just like roll it into a little ball.
Kind of even them out a little.
Mm-hmm.
Okay.
I like the colors we have chosen.
Yeah, these are like little moons right now.
They are. And so if you look at the pictures of the planets, you see they have lots of layers. Well, at least
Yeah.
especially Jupiter and Saturn,
Yeah.
because they have such a turbulent atmosphere. And all those layers are like the different ammonia crystals and the storm, so you can definitely see the wind patterns that are going on there. So we're going to simulate that by making layers of these Play-Doh balls.
Okay. Mine are not exact.
Oh, they don't have to be exact. This is not an exact science. All right. So now is kind of a fun part.
Okay. I'm almost done. Okay. Got it.
We're going to just squish them,
Oh, now we flatten them?
flatten each one. Just take the heel of your hand and just
Okay. It's like making a peanut butter cookie.
have to like make enough room.
All right. I have flattened.
All right. Now we're just going to stack them up. So like take one color and then the other color.
And then the other,
And just make a sandwich and just make
a tall sandwich.
tall sandwich of all 16 slices.
I did not make mine very evenly flat.
Doesn't matter.
So my stack is kind of leaning a little, but I think it'll be okay. Because it's nature, right?
Yeah.
So it's never
Nature is not
straight,
like
exact
geometrically
lines.
perfect. All right, so there's the
Okay.
start of it. Now just kind of squish it down. You might have to wrap your hand
Put
around
your
it a
hand
little
around
bit.
it to compress it. So we're compressing the stack.
Yep,
Okay.
about like that.
Okay.
And then you just take the whole thing and roll it up.
Interesting. Roll it into a planet.
Roll it into a planet.
We are the cosmos and the universe
Yeah.
making a planet in space. That's cool.
So you can go as far with this as you want. You could just leave it like that. This
That's
kind of looks
pretty
like
cool.
Jupiter.
Yeah.
Or you could do more. You could like
Mine looks like Uranus
kind
and
of
Neptune.
spread it out, fold it in half, roll it again, pinch to like seal those edges together, and then roll it up again and see what it does. The more you roll it, the more blended it's going to be. So the first time you're going to get really sharp stripes,
Like this.
but then if
Okay.
you keep on working on it, you're going to get more kind of swirly patterns in it.
So this is the first round. So then I'll flatten it and bend it in half. And then compress it. The pressure of a planet, right?
Yeah, so much pressure.
Compressing the planetary core in.
You can see the one I made last week is already all hardened up there.
That
you
one
leave-
looks like the Earth.
If you leave it out for like 3
at those
days, it'll turn
colors.
into a rock. You can keep it.
Oh, now I have a huge purple stripe.
Nice.
But that could be a storm on my planet.
Oh, and then you know another thing you could do if you want the lines to be kind of more, because this is just all swirly, but I think I'm going to roll it into a little bit of a cylinder.
Okay. And that will make some more lines.
And then I'm going to twist it. Take a look. Just very gently give it a twist.
Oh, and that'll give you...
See how it kind of
wind.
Draws it into the stripes? This is the wind on this planet. Just gently giving it some stripes. And then after I'm done with that...
Okay, I'm turning it, twisting it. Oh, it's getting some styration in it.
Yeah. And then after you've got it all twisted up like that, you can roll it back into a ball and see.
Compress.
It looks more...
And then make a ball.
It almost looks more planet-like.
Oh, wow, that really does look more planet-like.
Yeah.
So that was...
So I think I'm about done with mine.
Yeah, that
How's yours
looks
coming?
great. It's doing okay. I still have a big purple spot.
I like your... Oh, it's the storm.
It's the storm on my planet.
I like your colors.
I have a big storm. But the rest I really do like the way it turned out. Looks like wind. There we go.
Nice.
We made some planets.
And our colors match. Look.
Yeah, I made these two planets.
I made these two.
So, thanks for joining us today. Hope you learned some fun things about planets.
I know. I love the planets and stuff like that. Thanks for watching STEAM Kids Virtual Classroom.
See you next time.